presentation thing. Yep. Got it. Yep. Okay.
Okay, great. So it's a pleasure to welcome Tobias Osborne. Early in December, I had a suggestion from a friend. I started playing with Claude Code and got a little bit excited after being quite skeptical for a while. I looked to see around who was kind of using it, and although there were loads of coders who were kind of getting really excited about it, the only physicist I saw was Tobias, and kind of got interested, looked through his repository, and he was struggling with kind of similar questions of verification, and we're very fortunate to have him here today. Tobias got his PhD with Mike Nielsen, who wrote the textbook on quantum information and computation. His background is in quantum information theory. After doing his PhD in Australia, he actually was in the UK at Royal Holloway for a while, and he's now at the University of Hannover.
Fantastic.
Welcome.
Thank you very much. It's a wonderful pleasure to be here. I haven't been to UCL in a long time, and I was very much looking forward to visiting the UK again, especially as a dual national. Did you know that you need to have a British passport to visit the UK now? I had to scramble to get a UK passport, but now I have one, and I'm allowed to come back to this country. So it's a great pleasure to use my passport and come through the gates and come back to UCL again, which I have very, very fond memories of from all those years ago. And but I'm not going to be talking about the stuff that I used to be talking about. Things have changed. I'm not sure. We'll see in a minute what your background is, but it would kind of be hard to ignore the fact that in the past couple of months, years, that AI has probably entered your lives in some way or another, whether you want it or whether you're not. You are interacting with AI tools. Some of you maybe proactively, some of you maybe not. Reactively, also maybe you're a bit unhappy about the AI tools that are being used and forced upon you. I thought it was important last year when I started to sense the buzz in the software engineering community, of which I'm sort of peripherally attached. I thought it would be important just to take a sort of sober look as a research scientist to see, does AI or do AI tools have anything, are they relevant for us? Should we take them seriously? Should we take a deeper look at AI tools? And I did this in Q4 of 2025. I mean, I've been always sort of flirting with AI tools for many years, but I went kind of deep in the last quarter of last year. And my summary, and that's what I want to share with you today, is I think we better be engaging with these tools. How to engage is up to you. What it means for your lives is up to you. I'm just going to share with you my journey and the things that I found interesting and that I think are important to be aware of as research scientists as we enter this new AI era. They're not going to go away. And so now maybe the best thing to do is to get educated so that you know is what's going on. There is a whole other talk I would love to give about education and AI tools. I'm not going to do that. That would be a fantastic and very lively debate, I think, if we were to talk about education and AI tools. I have my opinions. We won't talk about that. That's not the purpose for today. Today's purpose is to understand how relevant are AI tools for research scientists. If you want to do your daily job in the area of research. We'll touch on admin as well. I think AI tools have an important role to play in admin, and we will potentially also touch on that. I'm totally YOLOing this presentation in various ways, and at the end you'll see how I've done so. Expect things to go wrong, and in fact that's the kind of way of working now, as you'll see. So maybe some demos will work, maybe they won't. What you'll take away from that is what it's like to work with these tools. So that's the kind of backstory. That's why I'm here today. And I'm entitled at large language models because that's what I've spent most of my time engaging with. Of course, there's a whole other top area of AI to do with reinforcement learning. I won't be touching that, but we could talk about that. So that's kind of like the why of this talk. Here's another why, maybe a bit more in your face. You probably saw it, 13th of February apparently, feels like a year ago. GPT 5.2 derives new results in theoretical physics. Do we got to worry? Do we got to worry that GPT 5.2 is now doing the job of high energy theorists? Maybe. The authors of this paper are not unknown. There's some very serious authors, very serious scientists in high energy physics who successfully, and I can confirm, it was a they successfully carried out a research result assisted by AI. I think is the best way to say it. I am no fan of OpenAI, and their press release culture is certainly nothing that I like. It's not so amazing as it is presented in this press release, but I think this paper alone should already demonstrate that other people think that it's helpful, and not just random people who are dabbling with AI tools. Rather, some of the world's greatest researchers are already engaged heavily in AI tools, especially in the US. And they are using them, at least they find them to be helpful. I want to frame this whole presentation in a bit of a timeline, just to give you a sense of where I see things being right now in this space. I think there are three key moments in the development of LLMs that are very important for us as research scientists. The first one was, of course, ChatGPT launches. I mean, I'm involved in an AI research institute. I saw the GPTs before ChatGPT, so it wasn't a surprise to me. It was just a continuum. But what was kind of surprising was the utility of ChatGPT was dramatically more than the previous GPTs. And you all experienced it, I'm sure. You've experimented with ChatGPT in November 22. And there's kind of, from an external perspective, you might not have sort of noticed things change so much. Like, every so often some AI company announces some new model, blah, 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 and then you go back onto ChatGPT and it all seems to be kind of the same, right? But there were some critical things that happened last year that you should be aware of if you're not aware of them already. And that was not in the space of chat. Instead, something very important happened in the first quarter of 2025, something deeply significant that I want to talk about today. And that is that Claude Code, which we'll talk about in a second, was released in February of 25. And that was definitely an inflection point in the development of AI tools. Maybe you've not heard of it, maybe you've not experimented with it, I'm going to tell you all about it today. And then there was a second inflection point that happened in November of 2025, and that is that the next generation frontier models were released, and they were significantly better. So there is a narrative, a comforting narrative in that you will hear, oh, the AI tools have peaked, they're not going to get any better, we don't have to worry. There is some basis for believing that narrative, but there are also moments when the models do have a jump in performance and utility. And I would say from a user perspective, that really did take place in November 2025. And the cold hard reality is this: if AI tools did not get better from November 2025, if that really was the peak, then we really have entered a new era of utility. And I hope to sort of give you a sense of why I say that statement. The reality is they are getting better, and they are going to get better. And they're even better again in January, and they're going to get better again in March, probably March, April, when the next round of models drop. So I don't see any real reason to believe that this narrative that they're not getting better. On the contrary, my experience is they are getting better. Okay, but before we move on, I want to get a sense of where you are in your journey of engaging with AI tools. Can you give me a show of hands? How many of you have used chat in some form, like ChatGPT? I hope I'm going to see almost everyone put their hands up in some way, right? Okay, already. So there's already some people are like, I'm not going to engage with chat. That's cool. Okay. Now keep your hands up. Have any of you used an LLM in an IDE to write code? Okay, ooh, a full 50% or so of the audience. And finally, how many of you have used a coding agent, like Claude Code? Okay, so that's, 4, 5, 6 people. Now, I was someone who had experimented with chat in July, August last year, and I installed Claude Code in November when I heard several industry insiders talk about this tool. I'm going to tell you about this tool. It's incredibly important that you're aware that this tool exists. I'm not telling you to install it. You don't have to install it. I'm not telling you to use it. You don't have to use it. But be aware that this thing exists because other people will use it. All right, and And I'm framing this whole discussion in terms of research science. Yep, sorry. Or I'm in the way, is that right?
Yeah, you can move to the, yeah, perfect.
I have to stay here, is that correct? I'm not allowed to move around. Okay, sorry. Good. Your experience then, as you all dabbled, more or less all of you, with chat, you probably had the same experience that I did last year and in the previous years. And that is, you probably dismissed it for research, right? You probably tried, if you didn't, I'm kind of like, I'm a bit disappointed, right? But, surely there was that moment where you were like struggling with a research problem and you're like, ChatGPT, how would I solve this? Privately, no one has to know that you're asking ChatGPT. And then ChatGPT, it gave you an answer, right? And you got excited because like it looked great, right? You're like, oh my gosh, like it's using these cool tricks that I never thought of. It's this method, I never thought of applying that method to this problem. Wow, it looks fantastic. And blah, 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 blah. It generates a long amount of tech and the equations rendered perfectly. It looks amazing. And then you look at it and you're going, this is hot garbage, right? This is hot garbage, what it generates, right? And I'm still pretty pissed, right? Pretty pissed at the models of 2025. Right? It was wrong in the worst possible way, right? It was not wrong in the way where it was wrong. It was wrong in the way where the equations looked correct. It was wrong and they were very convincing, right? That's the whole way these things are trained. Right? They're trained to be good at predicting natural language. So the equations look fantastic. And then you're like, hang on, this derivation looks a bit off. What's going on there? And it goes, oh yeah, of course. Oh yes, yeah. Sorry, this is not correct, but this would be correct. And then you're saying like, there's a bug here. Oh, of course there's a bug. Yeah. So the sycophancy of the models of 2025 were quite counterproductive. So I've wasted, and I openly admit that I've wasted a lot of hours of my life trying to get any utility out of LLMs in 2025 for research. And my conclusion still is to this day that those models were not fit for purpose. I don't see how you could really have used those models to really help you do research. These are terrible qualities for reproducible science. It's a disaster if you use a model that's sycophantic, that hallucinates, that has no fidelity, that will happily even reject true statements in order to agree with you. Those models were disasters. However, every AI company knew that these were terrible features and they've been working on this. And so they have been improving. And there are some models that are better than others for that. So one thing that I want to emphasize, however, and keep it in your minds for the whole talk, is you must always suspect that every single thing that an LLM produces is a lie, that they're cheating, that they're stealing, and that they're flattering. So as long as you have that in mind, this is an excellent model for these tools. It keeps you in the right frame of mind when you engage with them. So yeah, LLMs are incredibly capable, but maximally untrustworthy. You cannot trust them. Even now, even the models that are amazing, you cannot, but there are ways to trust them, and that's what I want to talk about. So here's my model of an LLM, and I think it's a good one to keep in mind. You're going to maybe ask questions, and then potentially I'm going to throw this back at you, right? You might ask, what if I wanted to do this with an LLM? And I'll say, would you expect a slightly unhinged, hyper-motivated MSc student to be able to do that? And that's the answer to a lot of questions. So, the slightly unhinged, definitely. Hyper-motivated, definitely. Master, definitely, right? You hear Sam Altman and whatever, they go on about their, Musk, they go on about their PhD level things, but this is all bullshit and we know it's bullshit. But master level, maybe. Although, actually, I came to the conclusion that they were correct about PhD level reasoning. Because most PhD students, or at least when I was a PhD student, I spent most of my time like playing computer games. So at that level, they're pretty on the money. Okay, so there's a gap, right? There's a gap from your experience. Most of you have tried chat. Most of you probably have tried doing some kind of research with chat, and you had a bad experience. And then there's there's these other people like me standing here saying, hang on, there's something important going on. There's a gap. And that gap is, I tried ChatGPT and it hallucinated, and then there's people who are saying like, wow, this is really powerful. This is like a force multiplier. I want to put it to you that that gap can be closed, but that gap can only be closed by, it's not closed by better models, actually. It's not closed by better models. But it is closed by technique and domain expertise. So what I want to put to you is that the human expertise is critical, vital for multiplying or multiplying the capabilities of an LLM. If you have no domain expertise, then LLMs will just multiply your ignorance. They're very good at that. It's going to multiply your domain expertise. So that's what's crucial. That's the human element that still remains. I don't believe we're going to be replaced by AIs anytime soon. But I've said all kinds of things, and they were wrong. I mean, I've been wrong a lot, like a lot. Okay, what does it take then? You're here because you're curious. That's great. Like, what does it take to use AI tools as a force multiplier instead of just like for idle chat? It takes several things. I'm going to try and introduce you to some of these things and then convince you that this is true. And then maybe you want to experiment, maybe not. That's cool. You know, it's just, you know that it's there, right? It definitely takes practice. Like, you don't want to hear it. Nobody wants to hear it. But, you know, if you pick up a guitar, right, you don't play the guitar instantly, fantastically, right? If you've never touched a guitar before. You pick it up, you strum it, it goes, brown, and then you're like, this sucks. So that's, you know, why does it suck? Because you haven't practiced it, right? You don't know where the notes are, where the fretboard, you haven't learned the fretboard, et cetera, right? It takes practice. You have to engage with an instrument before it pays you back, and you have to practice. Industry insiders talk about 1,000 hours of practice. I think that's about right. From my experiences, I probably put in somewhere between 500 to 1,000 hours now on experimenting with LLMs. And I feel like I've gotten to a place where I know what to do. And the first 100 hours, they kind of sucked. So it's a fact. It takes practice. And the next one sucks as well, right? Free chat is not good enough. And I'll explain exactly why. Why it's never be enough. You'll never get good with the free models. And that means you have to pay money. You have to pony up some cash, right? And how much? Well, you know, it starts with at the kind of, you know, gateway drug of 20 euros a month, and then you'll be soon, you know, you'll soon be sinking 200 euros a month into these models. That's up to you. I mean, I'm doing it. I freely admit that I'm paying not OpenAI. I'm paying Anthropic for a subscription. You know that. Be aware that I am paying for these models. Like, be aware. Take skeptically any comment I make about Anthropic models. And I think it's very important that you learn what these coding agents are. And I'm going to tell you about those today. I think that's really critical. That is the phase transition between productivity and non-productivity. If you're cutting and pasting stuff, then you're doing it wrong. Okay? So that's the take-home message. You'll get it at the end. So what can you do with these things? I mean, magic. You can do magic with these things. It's just, everything now that I look at, I'm regularly astonished and amazed by what can be done. It's now possible to just auto-formalize math. Like, no human in the loop, like barely any human in the loop. I've given it master level mathematics, unpublished research, not appeared in any training data set, and I've asked the AI tools to formalize with the lean formalization language, the maths in these research results, and it does it automatically by itself, on its own, and in the end you have a formal proof of things. That's non-trivial, took a bit of practice before I could do that. Writing new science is possible. I have actually been able to use AI tools to get new scientific results. It was not easy. Yep.
I can trust that the proof is correct, what is formalized, but the exercise of formalizing what you write in more ordinary language, do you have to check that?
You have to check that. What's the brittle point of a formalization? The definitions, right? The proof is formally correct in a formalization framework like Lean. The definitions are semantically unclear, right? That's where you need the human. Did they formalize the thing that you think that they formalized? You know, if they defined a matrix, did they prove a statement about matrices, or did they just define the matrix to be a natural number, right? So you need to look at the definitions. So there is hard work to be done, and that's in the definitions, in the semantic. You'll hear me say that a lot, in the semantic correctness. It is possible to accelerate research. and with the correct tooling and expert guidance, I'm not allowed to move right, with the correct tooling and expert guidance, and this is it's such an important point. I also want you to take home, the human provides the ground truth here. The ground truth is always the human. It's never ever, the machine. Don't let an LLM tell you something's true. You get to decide that. And they can be understood. So they may seem a bit magical. Okay, like who here feels that, excuse me, ChatGPT and LLMs are kind of magical? Like mysterious objects, you know. Who here totally understands them? Right, let's deal with that first. So I'm a physicist, right, by training. I like this kind of reductive approach. Let's just pull things right down to the building blocks, understand those, and then rebuild up everything from that, so that we get rid of that magic. Because I hate magic, right? Magic is when you don't understand something. And I want to take the magic out of LLMs so that you just like, ho-hum, I understand that. That's where you want to be when you engage with AI tools. All right. So what is an LLM? Well, from the outside looking in, it's a function. It's a function that takes a string and it emits a string. So outside the boundary of the API, and we'll talk about that in a second, this is the observable behavior, right? There's no hidden state carried between calls. And you're like, huh? That doesn't seem to correlate with my experience with ChatGPT, but we'll get to that. So an LLM is a function. That's the first take-home message. It's a non-deterministic stateless function. It's stateless, so that if you evaluate that function and you evaluate it again, it doesn't remember what you did in the first evaluation. So an LLM is a stateless, non-deterministic function. Each evaluation is independent. There's no memory between a call to an LLM. And you'll see why that seems to, be such odds with your experience with ChatGPT. It's non-deterministic. So if you ask an LLM if you give an input to an LLM, and then you give that input again, you might get a different answer. So that is an absolute fundamental part of the transform architecture. I will now try and get that to work. Let's see. What am I going to show you? Hopefully, I'm going to show you that LLMs are non-deterministic stateless functions. Is it going to work? Is it going to work? Okay, I'm calling now Claude with a question. And as you see, it's giving a different answer each time. So the question was, invent a funny name for a hypothetical subatomic particle and explain what it does in one sentence. And there you go. You can see different answers. And you can see on the left, I've got this t equals 0, 0.3, 0.5, 0.8. I'll explain that in a second. But the key point here is that I gave this function, the LLM, which is Claude's, the model Claude from Anthropic, and it gave back an answer, and the answer was different sometimes. Sometimes not, sometimes different. But it wasn't the same every single time. So it's stateless, but it's not deterministic.
Tobias, why is it giving a similar name?
I also wonder at. I mean, I think that this prompt of funny name for a hypothetical subatomic particle, like it just seems to have activated that weight in the training data that it thinks procrastinon is funny, right? And I've sent this query off maybe 50 times now, and it always comes back with procrastinon. Is there no other funny particle out there? Okay, so it's non-deterministic. Same input, different outputs, and the model samples from a probability distribution to give you that. So it's a probability. What does it actually output? An LLM actually outputs a probability distribution, which you then sample from. And how does it do it? Effectively, it does it just like you would do in a statistical physics course with the Boltzmann machine. It assigns a probability to tokens. I'll tell you what a token is in a second. It's really a direct analogy to the Boltzmann distribution, and it'll sample these things called tokens, one after the other, from this probability distribution. And you have control over one parameter here, and that's this temperature T. And that was that T that I had in the left-hand side of the window. I was asking Claude to give me answers at different temperatures. So what the first answer that you saw, the T equals 0, that's where the temperature was set to 0. So if in fact I queried Claude over and over again at that temperature, I probably ought to get exactly the same answer at each time. I don't think that's the case because the actual way that the models evaluate still have some non-determinism in them, but I haven't tried that out. But as I increase the temperature up to the top value of 1, you gain different ones. All right, so that's the temperature, and yeah, there's 2 limits that are important. Okay, infinity equals 1 in the API for Claude. Yeah, and so that's how you can already understand what an LLM is doing. It's a function, it takes an input, it outputs actually a probability distribution, and then it samples from that probability distribution at some temperature. Usually for chat online, they set the temperature quite low. They don't really like it to have variation in the answers, but if you have API access, which is anyone can get for a couple of euros, you can change with the temperature and you get really wild stuff coming out. What do they emit? They don't actually emit words or characters, they emit things called tokens. Tokens are somewhere between a word and a character. They're about 4 to 5 characters. There's a vocabulary of a fixed dictionary of them. There's about 100,000 recognized tokens for an LLM. And there is an example of the words theoretical physics being broken up into tokens. It's called tokenizing. Tokenizing is the first step to making a call to an LLM. Anything you type will get tokenized. And that means that an element isn't really a map from strings to strings, it's actually a map from the infinite language of tokens to the infinite language of tokens. So. And what is an LLM? Yep, the question? Well, I mean, it'll say it, but it has to break the tokens up in just the right way so that it can create that word.
That's always possible.
Yeah, I mean, so the 26 characters are also tokens, right? So it's just that it's more expensive if you emit single character tokens. So tokens are quite convenient, right? Because that saves on, you're already making a huge compression, right? You're spending a lot of energy and water to just get one of these calls to execute. The more you can compress, the better for everyone. All right, so what's an LLM call? It's a forward pass through a frozen neural network. It's not changing, it's frozen, it's trained, and there's no learning and there's no state mutation. So you're like, this is no way what ChatGPT is doing, right? When I talk to ChatGPT, it remembers what I said and we have this conversation and we become friends, right? How does it do that if it's just a forward pass through a frozen neural network? Well, the answer is what I'm going to explain in a second. But before we go on, I want to leave. So, by the way, I'm sharing these slides on my GitHub. I'll show you that presently. You can just download everything I've done here. So you don't need to take notes or anything. Like, it's all here. Everything I'm showing you, you can get straight from my GitHub. I'll share that link with you later. Before we move on, I just want to give you some pointers to some really great tutorials on how the actual architecture of an LLM, how it actually works, like in reality. And I think that everyone here is like super well trained enough to understand this material. You need to know about matrices, and you need to be able to multiply matrices and vectors, and you need to know about probabilities. And if you know those things, then you're golden, right? So all you need to do is that you find a tutorial that resonates with you. And they're hard to find because there's kind of all this kind of blah, blah. But here's some references that I found quite helpful. There's the original paper by Google, the Attention is All You Need paper. Then there is Andrej Karpathy, who's a well-known figure in LLM development, and he's got an open source GPT you can download and write yourself. There's a beautiful article by someone called Jay Alamar called The Illustrated Transformer. He goes through it step by step, really like step by step how a transformer works. And then just for funsies, I wrote my own GPT, so in Julia. So if you, that's a super mini version of a GPT. And don't ask me what the acronym GPT means, I always forget. All right, so LLM is stateless, non-deterministic function from strings or tokens to tokens, and it samples from some probability distribution in a single forward pass through a frozen neural network. So why is it that you think you're chatting with someone or something or whatever? Why is there this illusion of intelligence? And the answer is, it's so ridiculous that you'll be just like, this is the stupidest thing I've ever heard. What they do is they take your prompt, put it into the thing, and then it emits a string. And then to make it feel like you're chatting with an entity, the next time you type something, they take everything you've typed, and then they put it back into that function again. So it's like this is I never would have I just never would have come up with this because it just seems so stupid, but this is what they do. It actually it's amazing. It actually really works. So LLMs are token predictors, right? Their whole job in life is just to predict the next token. There's no intelligence. They just predict tokens, and the more context you give them, the more history, the better they are at predicting the next token, the next word. So that's that's how. Yep, a question.
There have been people that gaslit these LLMs by changing
We're changing the.
No, you just said that.
Yeah. It trips them up, right? Because what is it tripping up? It's tripping up a single stateless function, right? That's non-deterministic. So you input a different input, and then it'll do its best with the input you give it, right? So the takeout, when I heard this, I had to read it 2 or 3 times. Yep.
So is each term behind the term categorically independent?
Say that again.
So you've got this term here.
Yeah.
User and user response user. But are those terms independent of each other?
Yes, in the sense that what comes out, turn 3 is that I've frozen the previous turns, and then I'm going to input that into the LLM, and that output is absolutely independent of turns 1, 2, and 3. It's stateless and it's non-deterministic. An LLM does not remember your conversation. What it does, it remembers because you're just putting in the whole history of the conversation as the input. That's why it looks like it remembers.
So is there a limit? Like how
Oh yes, there is a limit, and this will explain. So is there a limit? Yes, there is a limit, and I'll go into details about that because it explains a lot of things. Here's what actually goes on behind the scenes. So if you interact, or even the chat clients like ChatGPT's client, OpenAI's Claude, Anthropic's Claude, they all do this behind the scenes. If you want to interact with an LLM, you must make an API call. An API call is something that goes through over SSH, effectively HTTPS call, and that's what gets sent. This is the literal text that will be sent to the API that's exposing the LLM function, and you can see all the stuff that goes in there. You need to have a key, you need to have a content type, you need to have a version, you need to have the model, you're calling the number of tokens, so you know what tokens are now. There's 256 tokens there. And there's the messages, and everything that gets sent to it is a JSON query, so if you know what JSON is, then that's what it is. It's just a role, user, content, and then a string. And so, for example, we could just do that right now. We could say, let's just do a call to open, to Claude. So I've got a call here that I want to do. It's exactly that text you saw on the slide. Let's do it. Let's see if what Claude has to say about what is a quark. There it is. So it's a bit uglified because it's in JSON. So I'll just do the call again and then make it a little bit prettier for you. So I'm just literally calling that LLM function, that stateless non-deterministic function, and there's all the output to the function. So what it sends back is this text. These are the tokens it sends back. So the tokens include the little squiggly brackets, right? So it says the model was this, blah, 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 the content was this. Here's the text, right? That's its answer to my call. I apparently used 13 tokens in the input, and the outputs were, I don't know where it says it, 256 tokens, right? So that was the call. I could send that over and over and over again all day long, and if the temperature was low enough, I would always get the same answer. How do we have a conversation about quarks? Well, then I would have to take this answer, stick it into a longer string, and then put, the next part of the discussion in. Yep.
So here the text is like sort of cut off. It reaches the maximum.
It reaches the maximum.
Is it aware of like what's the token?
Say that again.
Is it not aware how many tokens it used up when it generates the end of the text?
There's 2 hard limits. So either I say 256 is the limit, in which case it stops there, or it'll wait for a stop token. So if you say the limit is 1 million, if you should be so lucky, then eventually it'll emit a so-called stop token, and then it'll just halt there and send it on. Yeah, a question?
The answer it gives you doesn't reflect the number of, what the maximum number of tokens is.
Does the
Because it stops mid-sentence.
Yeah, does the answer give you respect the maximum number of tokens? No. In practice, not really. It depends on, there's some other factors that depend on, they get a bit stressed if they know they're coming up to a token limit. Maybe we'll get talked about that. Okay, so that's what's actually happening in a chat client behind the scenes. It's emitting JSON queries and sending JSON queries backwards and forwards to an API that interprets these and sticks them into this function. You can do it over HTTPS if you wish, and it would look like that. It's just a post. Yeah, and that's chat, right? That's how chat works. So I just want to emphasize, because this is there's this sequence of understandings you need to make before you can profitably work with an LLM. And the first one, if you don't know it, you should know it now, is that LLM has no memory whatsoever. There's no memory. If you call it, it'll just can't remember to talk to you last week. And the client, that's the stuff that's wrapped around the function. That's what's creating this illusion that it remembers you. When you go on to yep, a question? So the question was, these clients, you seem to be able to set parameters like your name and stuff like that. Like, how does that work? The answer is they stick it in the prompt, hidden behind the scenes. You don't see them doing this, but they're taking all this information, and I'll show you in a second, and they're sticking it into the prompt. So a prompt, when you actually interact with chat, this is what's really getting sent. There's something called the system prompt. You never see that. It's very hard to get access to that. Jonathan was telling me how to get access to that for Claude. There's a whole bunch of hidden instructions that you don't know about that in every single call to this function that they send into the function. They prepend it to the text, yeah?
The maximum number of tokens depends on the subscription?
The maximum number of tokens depends on the subscription, absolutely. This is critical as well. And so when you input, when you have a chat, like what's it doing? It takes the whole conversation history, prepends this stuff that you've set, and some of the stuff you haven't set, like stuff that it's observed about you. Like, there's a whole bunch of stuff in that system prompt that you don't know about. And it prepends that, then comes your conversation history, and then poof, you put it into your function, and it emits some tokens, and then it globs them onto the end, and then reinserts. Yep?
And the total number of tokens, like this limit, is it per day, per chat window, or per user, or all of them?
So the question was, these limits, what are they per day, per user? The answer is kind of all of them, but I'll try and break it down. For ChatGPT, the open model, free model, I think it's 8,000 tokens at last check. I'm probably wrong on that one. Someone might know better. Yep.
If my understanding is correct, every time you run something into the model, it will have to process all of the history, all of the tokens that happened before. How does this not become extremely unvisible, extremely fast?
Very good question. If you understand it correctly, it has to process everything that came before. How does this not become more expensive? It does become more expensive. It becomes quadratically more expensive, right? As the context window, which is the whole input that you have, gets bigger, it gets more expensive to evaluate an LLM. We'll talk about that in a second. So the conversation, in many chat scenarios, you think you're having this nice long conversation. You start at the beginning of the conversation by saying, my favorite Smarties are blue. And then you have this long conversation, and then sort of halfway, a little later, you get this funny feeling, like, something funny, isn't there? What were my favorite color of Smarties? And it has no idea, right? This kind of weird amnesia that chat gets. What is that? That is having filled up the context window. And they're just dropping stuff silently from the conversation so that you can continue to have your conversation.
How could they decide that?
How do they decide that? I don't know. Magical, evil, billionaire stuff, right? Whatever to keep you addicted. Whatever it is to keep you just coming back. But that's a failure mode that you need to be aware of. Like, context window, context management is one of the main tools you have for interacting and controlling your interactions with an LLM. Understand your context window. How much have I used? How much I haven't used? And when you use too much, start a new chat. Does that mean you have to start like, Groundhog Day, from the beginning again? Yeah, you do, right? Or the memento, you wake up, where am I? You have to that's the life of an LLM, right?
Doesn't the context window just shift in one chat?
Well, does it?
I don't know.
It depends on the client. Yeah.
Like chat can remember things from different conversations.
It can.
And this must be somehow getting information outside the current context window.
Okay, so there were two questions that were essentially related. Do the context windows just shift? And they seem to remember things from other conversations. So what they're doing is that they're actually summarizing stuff. Behind the scenes, the client is summarizing stuff in previous conversations. That can happen on your local computer, it can happen on theirs. And it's being stuck into that system prompt. That's how it remembers. Yep?
Is there a way to access your system prompt?
Jonathan was the one who was... Yes, you can kind of access it. Yeah, but only for...
Sweet talk it.
You can sweet talk it. Only for Claude. I think ChatGPT is impossible.
ChatGPT, yeah, OpenAI won't let you, but Claude, if you're very nice to it and keep checking in with it that it's doing okay, it will slowly reveal it.
So this is a crucial moment to say don't anthropomorphize these things. Which of course I do, you can't stop yourself. But take responsibility for every interaction with an LLM. You're the one responsible for what it produces. The LLM is not. This is a very important ethical point. Okay, so yeah, the context window, the shorter it is, the worse your experience. How can you get a bigger one? You can pay for it. Effectively, it's the only answer I can give you that's satisfying. You can download an open model, but then you need to have extremely expensive hardware. What kind of context windows can you expect? Yeah, 200,000 now for the frontier models. Pretty good. There are now 1 million context windows that I'm very happy have been released.
And Tobias, just not so is that 200 key, the neural networks, the input?
It's literally the input size, yeah. I understand that they have internally in the AI labs that they have bigger context windows. Okay, so as the context fills, older information is getting buried. It's getting buried in ways that are opaque. You'll never know how they do it unless you build your own chat, which you can do. The model's effective attention degrades. So as it gets bigger, this context, the attention mechanism in the transformer actually performs worse. So there is a sweet spot. You want to be around 40% context usage. And your instructions all silently disappear. That's why weird stuff happens, right, in chat. And there's the system prompt that we've talked about. There, all kinds of hidden stuff is buried in that system prompt, including previous chats, including your settings, and all that sort of stuff. So yeah, what's the message here? Chat is a loop. Memory is an illusion maintained by the client. So that so far is just kind of like explaining chat to you. But now I want to explain to you something dramatically more impactful that these LLMs can do, and that is agency. A LLM agency. So there's two ways in, right? You have this web interface, which is just a big wrapper around this function, and then you also have the terminal, which you've seen me do twice now, interact with the thing on the terminal, like with the API call. And that allows you to do some pretty impressive things. So what you can do, and it's just an insane thought, but what you could do is you could allow LLMs to have access to your computer. Like it sounds like, oh my gosh, no. What? Yeah, we're going to let an LLM interact with my terminal? Yeah, what happens if you do that? Let's play this game. So you can empower an LLM with the ability to run commands on your computer. So how would you do that? Well, it's actually very easy. You just take the output of the LLM and you scan that output for certain commands, and if those commands are there, you get your computer to execute those commands. You take the output from the command and you stick it on the end of the chat, and then you put it back into the LLM. This is the agent loop. The agent loop goes like this. While not done, response from the LLM is the system prompt, which you can't see, plus the history. Then it parses the response. It goes through what the LLM produced and looks for certain strings that are important. It then executes these tool calls that the LLM asked to do. It takes those outputs, sticks it onto the history, and then continue. So this is a coding agent. This is a thing which has access now to your computer. Why does it have access? Because you gave it access to your computer. You are parsing the output to do things on your computer in response to the LLM. What kind of things? Well, anything. So, okay, so here's the loop graphically, right? LLM emits a response, parses the calls, so I've just drawn up graphically this loop. What sort of things might you allow your LLM to do? You might allow it to have access to bash, the command line, the shell. You might say, you can just execute any command you want on the command line, like ls. You could list a folder. You could have it create a file. You could have it edit a file. You could have it read a file, and then you could have it execute Python. You could have it do all these things. All it's doing is this scaffolding around that function that is parsing always the output of the function and then just doing what the function says. So you describe tools to the LLM in some special input format that has been standardized. The LLM generates structured text requesting a tool call, and the scaffolding parses it and executes it. And it's just that simple. There's a nice article there there's a tutorial for how to build your own agent. But I want to point out to you that the LLM doesn't actually execute anything. You, the client, are doing what the LLM says automatically. So what tools would you need to do interesting things with coding agents? You would need two tools. You need to at least read a file, and you at least need to be able to write a file. It turns out because of the Unix, where Unix works, that's all you need. You can do anything with those two tools. So let's do something. I have here a coding agent. So this is Claude Code. Claude Code is is exactly what I've just described to you, but plus some fancy extra stuff. But it's at its heart, it's a wrapper around an LLM, and it's going to parse requests and turn them into tool calls. And okay, let's just do something simple. Write a program to say hello world. So now that got fed into Claude, the LLM, and it wrote the program, hello.py. Done, run it with that. No way, I'm not a peasant. So I want you to just pause for a moment and think what you could do if something had complete unfettered access to your computer. What's a problem that you're worrying about right now? What's a research problem that you're worrying about? Anyone want to volunteer one?
Delete the hard drive.
What was that?
Delete the hard drive.
No, I'm not going to do that research problem. If I did, it would do it. It would need sudo access though, but it doesn't have that. No. Any research questions that are interesting right now? Any volunteers?
Just make up data because it feels like
It could do that.
data points or something.
It could do that, but we would have to worry about checking that. So is there anything that any research problem that any of you are interested in right now that you're thinking about? You don't know the answer. Any volunteers? Yep.
Complete potential energy curves of iron oxide. If it does it, I'm going to read the out of the job, I think.
And what would make you happy? What would be an answer that would be like a good answer?
Spectroscopically accurate, at least the lowest 25 electronic state, using highest quantum chemistry.
Lowest 25, low, line. It doesn't matter if I type correctly, it knows what I want. Let's just see what it does with that. So the beauty is that Claude is, and all LLMs, right, they're very good at error correction, so I don't need to type it correctly. So it's just going to go do something now. We'll just leave it do that in the background while we're talking. Oh, okay. It's serious. Okay, what quantum chemistry software is available in my system? Well, not a lot, right? Okay, it's taking a look around, right? What have I got on the computer? Yeah, no software is installed. I can write a script. Fair warning, it's one of the most hard. Want me to install that? Yeah, why not? It may actually take a while. But we'll just leave that in the background while we're talking. So can I do that in a way where I can do the rest of the talk? So what I want to, we'll check in on it in a minute and see what it does. Yep, 5 minutes? Yep, okay. So Claude Code, I've now just shown you Claude Code. That's Claude Code in action, full action right there. It's going to install stuff, it's going to write code, it's going to execute it. I don't know if it's going to succeed. That's where human domain expertise is critical. You might look at it and you go, that's garbage, right? And then now begins the feedback, right? And this is the most important thing with interacting with an LLM. They have no fidelity, they lie, they cheat, they steal, they flatter. You need to give them fidelity as an expert, as the source of ground truth with feedback. And so the faster you can get your feedback loops, the better. So if you can say to Claude, that was hot garbage, here's why, then Claude will have another round and try and address that, and so on. And then if you tighten those feedback loops until they're really fast, that's when you can get research to go. Yep?
So is writing on like a good initial prompt not as useful as just having this?
Exactly that. Prompt engineering is dead. That's just not a thing anymore. It's feedback. Feedback is a key way to improve an LLM. Tighten up that loop. Make sure that you're telling it what's wrong so that it can correct itself and then continue past. And how does it correct? It's just re-inputting that entire history back into the function. Yeah, right? Let's see how it's doing. I'm so sad. It's going to take, I think it's, you see it's thinking with high effort. So it's taking it seriously, right? It's taking it seriously. That's the best I can say to you at this point. While it's doing that, I will, we have 1 or 2 more minutes. I'm just going to show you some of the stuff that I've been playing with Claude Code. It's amazing what, if you have effectively infinite cognition at your disposal, what that enables. So I've just been experimenting with Claude Code. Here's a couple of things that I've just done that I found kind of entertaining and interesting. 2 days ago, we had a discussion in our meeting room. We set up a computer, we had the webcam focused on the board, and we recorded a Zoom, and we were discussing on the board, and people were online and in person in the room. And I got Claude to transcribe the audio, to take photos of just to take the video and to excerpt the screenshots of the board, write LaTeX of what it saw, and then enrich the LaTeX with the discussion. And this is what it produced. So the kinds of stuff that you can get out of Claude Code, fully automated, like I didn't type a word of this, is something like this. This is completely routine. So this is, we had this discussion. Here are the people in the discussion, based on a Blackboard discussion, 3rd of March. It took that video, that crappy video of this Blackboard where it was barely readable, and it worked out all the equations. It wrote the LaTeX, came up with the definitions.
You have to keep correcting.
No. It's capable of now, the frontier models are capable of correcting mistakes in equations. So that was one thing. Here's something that a colleague of mine, Henrik Wilming, he was like, I hate all PowerPoint and presentation software. I want a presentation software that uses typest, if you know what that is. And it doesn't exist, and it sucks. And then he said, I just asked Claude to write it, and he wrote it, and in a weekend he had a presentation software that kind of did all the things he wanted. I'm doing that for Adobe Illustrator because I hate Adobe. Here's formalization, so I've experimented a lot with auto-formalizing maths in the way with this lean formalization, so we've got like dozens of examples here. I've also worried, that's probably for another time. This is scratching an itch of mine. I've always wanted a ray tracer, like ever since I played with Amigas. And it's hard to write a ray tracer. But Claude, you can just say to Claude, write me a ray tracer. Well, you need to plan it carefully. I wanted one that was physically correct, right? I didn't want this nonsense. I want one that could do stuff that's interesting for physics. And so I got Claude to write me a ray tracer that would physically correctly represent the spontaneous emission of an excited hydrogen atom in a magnetic field using limit light equations so the probability is conserved. So no nonsense here, physically correct. And because I have to teach the hydrogen atom, and you know that moment when you're teaching the hydrogen atom and everyone's like Laguerre polynomials. This is wouldn't it have been so cool, much cooler to have seen the probability wave function? Yep.
But did you check the equations it came up with in the code?
Yeah, I checked the equation.
Yeah, sure.
Are you sharing your prompts in your GitHub?
It's all of these are open, these GitHubs I'm showing you. So you can just look in the history. There's a handoff.md. You can see what I wrote.
So the prompts.
Yeah, you'll be surprised. The prompts are not, the magic's not in the prompt. It's in the feedback.
Yeah, conversation history.
Yeah, it's kind of that. You know, analog circuits, like I've never understood op-amps. Like, I really hate that. And then I got it to design me some filters, and I built them, like with op-amps, and tested them, and they worked. Yep.
I think at the start you said how reinforcement learning is a subset of AI LLMs. But these agents to me sound like they're doing trial and error based on their own output. But then without any input from you, so is there any similarities?
There is actually a lot of similarities here. Yeah, I think we're converging. What else? You can do, I'm clean rooming a linear program solver because I want one. Here's, I have videos on YouTube and I don't have any script, right? No notes from the videos. And people always write to me and say, can I have the script for the video? And I'm like, no, because I don't have it. And then I just got Claude to watch my videos and then give me the script. And so it auto one-shotted the script for my entire course as a 43-page PDF. And I checked this one, and it is correct. Every single equation. All right, I think I see a signal that I have to stop.
So let's just we'll take questions after, but let's first thank Tobias. And then people are some people have courses to go to, but we'll take questions for the duration. We have room for a while, but people should feel free to leave. And then one last thing, if you want to just, if you do want to come to the session tomorrow, after you played around with it for a while, feel free to drop send an email to that address. If you're just interested in meeting occasionally for lunch to discuss these things, do that as well if you can. Okay, so let me just wait 2 minutes for people to clear those that have to leave, and then we'll take questions.
Because otherwise you get completely mugged.
Okay, I need to go.
Yeah, I did forget. Yeah.
We'll take questions if
we met briefly before. No, absolutely. Yeah, very welcome.
I was on your the days of COVID. Sounds lovely to
Okay, we'll take questions if you can. If you want, there's a mic there to ask them, but Tobias will try and repeat. If you're leaving, can you please, those that need to go, can you please go and send Okay, are there further questions?
Yeah.
Thanks. About the video or something you did, I was just wondering. Thanks.
Hello. Yeah. About the video, I was just wondering, for that instance, did you have to install some extensions within Claude so that it would know how to understand voice, like voice recognition, or like how does it know? Because it's looking at a video with pixels that change every time frame. How does that work? How does he understand?
Okay, so I can answer that. That did require some extra tooling. So transcription, Claude can do it, but it uses by itself a software that you can download and install yourself called Whisper. Whisper is an open AI product, it's open source. So I just asked Claude to install Whisper. It downloaded the audio from a video, it processed the audio through Whisper, and then it had the transcript.
Okay.
For most of the applications, you just show that those are like executable results. Is it? Oh, sorry. There we go. Is it possible at the moment to use these agents to
say, do a lit review or something like that?
Is it possible to use an agent to do a lit review? 100%? Definitely. However, they hallucinate.
Yeah.
So what's the ground truth? The ground truth is a paper. So you say to them, download the paper.
Yes, exactly.
And string match the names, so it's not allowed to tell you the paper. You force it to download the paper to a subfolder, and then string match. They can do string matching, that's no problem. So that when it creates a lit review, you can look at it and you can go, hang on, you know, the political situation in Australia is not a paper on quantum mechanics, right?
But is it allowed to browse the internet or search
Yeah.
Google Scholar for you?
I will typically allow them to browse. You have to give them guardrails, like Anthropic's very big on guardrails, right? I just say you can do anything you want. So they can access the internet, they have access to the web. So they
advise your students to do that because it's a long and lengthy process of lit review.
Yeah, do I advise my students to do it? No and yes. So typically, our students, I force them through the following exercise. You know, take a paper you're interested in, now do a reverse citation search, so there might be 1,000 papers that cite it. Read every single paper. You know, 1,000 papers sounds insane, but actually it's not insane. You know, you can bucket them, right? Some of them are garbage, some of them are not. And then you're talking maybe a week's worth of work. But that's a very important job, right, to get to understand your literature. And then once you've done that 2 or 3 times, it's an algorithm, why not automate it, right?
Given that these are frozen neural networks, is there still a risk with uploading your like proprietary data, or like how much can get leaked back to the model basically?
Yeah, okay, so the question is, does stuff you upload get remembered
Yes.
and used? I think you have to assume it is.
Okay.
I mean, Anthropic, like, this is the model that I'm using at the moment. Their big sales point is the business to business, and businesses are very concerned about IP. And they say, we don't look at your data, but whatever. You know, what worth is the promise written in words on the internet? The answer is, I think you must assume that everything you send to them is being studied, trained, recorded. So that should also inform your behavior, right?
Also, on the topic of like literature searches and so forth, like, is there is it reasonable at reading, for instance, some of the older papers where like the text might not be like in standard like PDF format, and particularly where you have like tables of older data, you might not want to like process yourself.
It's amazing at that. Like, it's just incredible at that. This is one of those things that I'm just always shocked by. Like, you'll give it like these old typewritten manuscripts, and they have such good visual processing tools now that they can take a table full of typewriter, bad mimeographed tables and recognize all the characters. It's actually some of the simpler AI tasks is to recognize this kind of information, and it'll process it and turn it, automatically transcribe it. Not a problem. That one's good.
How much of your computer's own resources is it using versus online things? So if you were concerned about it deleting your hard drive, could you run it on a virtual machine and not suffer any lag?
So how much has it access to the device? It has what you give it access to. So they have permissions. So I turn all permissions off. I just let it do whatever it wants.
No, I mean, like, how much is it using your RAM?
How much RAM is it using? We can look in a minute, but I think it's in the gigabytes, because it's pretty shittily coded, like, let's be honest. They could be more efficient. But the actual LLM and everything, that's on Anthropic servers, so they're the ones paying the compute there. So at the moment, my computer is working hard, but only because it's running a Python program. Otherwise, it just needs a chat interface, so there's not that much compute.
Okay.
So, back to like how you drop things from your context. Do people do more clever things than essentially like just like linearly dropping things from context? And is that like proprietary, or would you have access to that if you have an agent?
You have access to that. So yeah, okay, context is the first thing you worry about when you start learning about these tools. And dozens of people have worried about this, hundreds, right? They all come up with their own solutions, and they're all open source. But there's two schools of thought. School of thought number 1 is the minimum context usage school of thought. You spawn an agent to do one job, it does it well, and then you kill it. So you use the minimum context. These are the context minimizers. And then there's the context maximizers. Those are the people who want to fill the context full of rich information that will inform it for the next job, right? That it'll give it maybe, I don't know, a couple of thousand tokens for the job, but it fills it all up. And then how do you do bigger jobs, right? Well, you do task decomposition. So there's this whole art form of task decomposition where you take a big, long, complex task and you chop it up into little tasks that then fit in context in these various ways, either minimizing or maximizing.
Mm.
So but there's so many tools out there. Lots of people worry about this.
Going back to the question of security, which you previously touched upon, I mean, you can see as a computer scientist why I would be quite worried to run automatically any code that Claude or any other LLM could give me, like code injections or introducing undefined behavior and a backdoor to my computer. Like
yes, this is 100% true. Can you? Can it do arbitrary code execution? Sure can. I just let it run a Python program, right? So I run it on a computer where I don't care if it gets burned, right? This laptop here is just sort of my work laptop. If I drop it in the river, I'm not sad. So if you give it access to your personal information, then that's bad. If you give it access to arbitrary code execution on a clean device, it's bad. Like it could, browse the dark web or something and do illegal stuff. I do advise that you watch them. But Claude's, Anthropic's whole reputation is based on these agents not doing that. But I can't say to you, you can stop that. You just can't. There is no, if it's got arbitrary code execution capabilities, it can do arbitrary code execution, right? There's just nothing you can do. And if a bad actor gets access to your computer, that's it, right?
Yeah, also, the code that the computer is executing is not only Claude, it's because it's installing something else.
It's installing libraries, yeah, right? So
libraries and executable files.
That's right. So it's a decision you have to take. Like, am I willing to go there or not? I mean, evidently I just decided to do it, and I have not had a bad experience. But that's like I haven't had a car crash yet. So this is not a great argument.
It will ask you, right?
Yeah, but what's your paranoia level, right? It asks you, but is that fake security? Like, is that security theater, right? Or does it really ask you?
And even if you use this other computer you're saying, which is safe, it doesn't have your say banking data or whatever. So that computer will still have your passwords and things, right?
Sure. Yeah. So could it hack out my passwords? Probably, right?
It could argue the issue is a vulnerability in a network of computers.
Yeah, it could introduce a vulnerability. It could.
And so you could automatically deploy an attack on, for example, the LCN.
That's very, I cannot say that that's impossible. But that doesn't mean that it happens, right? But there is a distance, it's the distance between these 2 points that you have to evaluate yourself. Is the utility worth the risk? And for you, the decision may be clear, right? But for other people, it might be on another side.
Hi, Tobias.
Hey.
So, thanks for a fantastic talk. So you mentioned at the beginning this sort of step change that you saw in the capabilities around November last year. And I've also noticed a big improvement of this sort of apparent understanding of mathematics. It seems able to, reason about advanced mathematics without making mistakes. And I'm wondering how is that compatible with this sort of model of a non-deterministic neural network? Have they put extra structures that do the mathematical reasoning, or is it really just a bigger neural network that has been better optimized?
It's sort of both. So it's a subtle and nuanced question, that one. It's quite difficult to answer because it's quite a lengthy answer, but I'll give you a sort of caricature. There is the so-called pre-training, right? They just have a bigger neural network. They throw a bigger neural network at it, and in-context learning, where you just fill up the context with useful stuff, that actually could get you 90% of the way to reasoning-like capabilities. And so, yeah, it's just making it bigger and better does give it reasoning capabilities. People don't quite understand why and how, but it's known, right? But actually, it turns out behind the scenes that many of the frontier labs are having extra scaffolding and infrastructure on their models. And there's something that you don't know that's going on, where they are using agents to critique agents. And I've experimented a lot with that because I found that to be incredibly powerful to increase reasoning capabilities. Agents are okay at reasoning, but they're much better at finding mistakes. So if you say, find the mistakes in this paper, then the latest models are fantastic at that. And so what you do to increase reasoning power is like you have now an oracle for correctness, right? Or probabilistic correctness. So you just introduce critique agents to look at a proposed argument and then you feedback that loop.
Right.
And so they're doing that behind the scenes, apparently. You don't see it.
Okay, let me try to formulate my question because it got semi-changed by the answers you gave him. So you're talking about the reasoning power and then by introducing critic agents to that are better at finding mistakes, and this kind of goes into, it's related to my question. So in my example, I would like to use agent coding to help me build a deep learning model that's going to be looking at satellite decay anomaly under geomagnetic storms, for example. So that's one of the chapters of my PhD that I like to build, and I need help for software engineering purposes because I'm not a software engineer.
Right.
So in the task that I'm giving my agents eventually, when I'll get there, how do I know, what I'm a bit confused into wrapping my head around is, how do I know that the agent actually understands what I'm really telling him? If we're talking about these tokens that are words, he's not a mathematician and he's keeping into memory a bunch of things I'm giving him, that he understands what my algorithm is doing without plagiarizing or basing himself in his probabilistic knowledge and calculations from his type of model, which is a large language model, and I'm doing a deep learning work, right? Mm-hmm. So how do I know? Do you understand my question?
So
it's a bit
I think
convoluted,
you're taking aim at kind of like several things at once.
Yeah.
So I'll try and answer it bits and pieces.
Sorry, it was a bit of a confusing question.
No, I appreciate the challenge, right? Because it is a difficult task. Let's just talk about how do we know if something's true? Let's just start with that one. So there's actually, humans have many ways to determine if something is correct. One is there's a formal mathematical proof, right? You look at it, every line is correct, and then the assumptions were correct, the definitions were correct, the derivations were correct, the answer is correct, right? That's ground truth from the level of formal provability. You can do that programmatically. That's one way of determining correctness. The second one is like, it compiles. So you know the code is correct, right? Because it compiles. Yeah. So the program is correct in the sense that it's correct Python code or correct whatever. But does it do what you want, right? So correctness is both the derivations are correct, but also semantic correctness. And I think you might be taking aim at semantic correctness, right? You know, is this thing that it's doing representing the thing that I think that it represents? And there's many ways to deal with that, right? And so one of them is consensus, right? You know, humans do this a lot, right? It's called publication, right? You send a paper off to a referee, 3 referees around the planet randomly agree that it's a good paper and correct, so now you have the consensus-based opinion that your result is correct. And that's the gateway for correctness for a lot of scientific publication. How do you know in your case if it's correct? Well, that's when you come to what's called test-driven development. I think I would put it to you that you probably have tests that you would run, right? And you would definitely insist that Claude Code execute those tests every time it makes a change. So these coding agents respond best when you have tests. So you tell them to write tests first. You don't even write them yourself, like get them to write the tests. And then look at the tests, right? You're the source of truth. Does it look like it's testing the right thing? You know, it says, you know, the orbital parameters are blah. And if the code runs correctly, it should get those orbital parameters. You know, something like that, right? You know, you look at the test. And then you say, yep, that's a legitimate test of what I want. And then it runs the code, and then it checks, did I get those orbital parameters? And if the answer is yes, then you go, well, probably is correct.
So does that go into the subpart called skills that we need to teach our Claude agent to have? Like if I say, within your skills, I want you to help me out, writing these tests to make sure that the inputs I give you, and you do this and that within my software, and then you give me this output, because I know what I want out of my project. For example, I'm not just going in blind, telling him to do what I do. So does that go into the skills?
I wouldn't put it in the skills. I don't interact with Claude like that anymore.
Okay.
I just tell it in natural language what I want. Let's see. I'll get another Claude Code instance.
I think that was the vibe in terms of when people were using Copilot
rather
than agents, where they would need to write a text file and put a bunch of skills that they want the Copilot to always follow to make sure they don't diverge into something else.
So we've moved on from that, to be honest.
Okay, well,
I think the models they've upgraded in the past 2 months. So they just know to do this now. So what we'll do is I'll just show you how I would type that once it starts. Here we go. Like the way I would type that, is I would say, okay, write a program to do, okay, you got to do a little bit, to do blah, blah, write the tests first. And that would be it, right? I would type that into Claude. Claude would go and then work out, maybe you tell it what language to use, maybe not. And it would just go and write the tests first.
I'm sorry, can I ask another question, if that's okay? But what about the tokens and the windows and the chat windows? Like if I use this up in a project, I'm going to have to explain that again to him. I don't know, tomorrow if I have to open a new chat window.
That's correct. So that's where experience comes into play. So the token window for my Claude is 1 million. So 1 million is pretty big.
Yeah.
In fact, you can put a whole PhD thesis in 1 million.
Okay, yes, that gives a perspective.
So even 200,000, you can put a thesis chapter in there comfortably fits in 20% of the context window.
Thank you so much.
Welcome.
I had a question about tokenization. Is it purely string-based, or did anyone experiment with trying to tokenize more than just the strings? Is it possible to tokenize, for example, mathematical logic, sort of touching on what Dan said before? So
tokenization is more or less to solve problems. So they just have small neural network classifiers that do that now. And yes, they do it for math. So you'll often see, I don't know if you've experimented with ChatGPT or Claude, they seem to write Unicode math equations now, right? Like they have a little integral symbol and so on. It's a bit ugly, but they do that. That's just, they're literally using Unicode tokens with math, yeah.
How much compute power does this use on the other side?
Oh well, now here we come to the ethical questions. Yeah. So I want to make it clear, or I should have made it clear at the beginning of the talk. I'm very conflicted about AI technologies, and I'm not entirely happy, and I think that they're doing harm as well as good. And one of the things that I'm very concerned about is environmental impact and costs, and how much damage is an LLM called doing. You can host your own LLMs on your own computer. They're small, they're dumb, but they work. And you can actually track how much energy they use. It's surprisingly little. So to do a query to a fairly decent model on my desktop computer at home, I don't know, for about 1 minute it's drawing 100 watts, so whatever that is, right? So, and the frontier models are they're bigger, but they're not orders of magnitude, like that many orders of magnitude bigger. So I think we're talking about like light bulb levels, but I can't give you a better answer because they don't disclose this, right? I'm just extrapolating from what.
Can I go first? Yeah. Since you mentioned that like the auto formalization works quite well, should like people writing maths and theory papers be including formalizations of what they do now?
Oh yeah. So this is one of my personal, I recognized a year ago, recognize is the wrong word. If you refereed any papers, you would have noticed a phase change in the past couple of years, right? You're just drowning in referee requests. And we've entered the era where people can one-shot a paper on the paid model of ChatGPT. It's a bad paper, but they can one-shot it. And we're going to be subjected, and it's already happening, you know it's out there. There are bad actors who are submitting papers to journals that are one-shotted from ChatGPT. It's a thing, it happens. And so this is, this is intolerable, right? We've reached a reproducibility crisis of epic proportions to the point where, I think publication is dead, right? The system cannot cope with the load. So how do we deal with this? Well, if you can auto-formalize relatively painlessly, why not make that a requirement of publication? So then the referee no longer has to verify the mathematical correctness of the bits that need mathematically verifying. Just they have to they have to check semantic correctness for the definitions, and they have to check, smell test, are these ideas like interesting or not interesting. I see no reason not to demand an auto-formalized proof for many things in a paper. Not all things. I mean, if you work in gravity, quantum gravity, it is challenging. I admit I don't have the answer there. Jonathan's struggling, and I'm struggling a bit there. But if you're working with anything that uses linear algebra or even like pretty high-level functional analysis, there's no reason not to formalize it now. I certainly won't referee anything that's not formalized.
Tobias, I just wanted to ask that there are probably browser versions of these things as well. Would they be less powerful than this one? Right.
They are less. There are browser versions, sure. They are less powerful because you're running the compute on some host somewhere.
Right. But can you give it access to your computer still? If
you don't need access to your computer, no. Okay. If you're pretty paranoid, then buy a Mac Mini, right? And then just don't put anything on there.
Right.
That's like the standard practice is buy the Mac Mini. I don't know if that's a good answer, but
So whatever. So the browser versions cannot access your thing better. I was thinking that if it can still access your.
The minute you allow access to your computer, then they can do arbitrary code execution.
Well, can I suggest we take 2 more questions, one each, and then we'll draw this to a close. But then we'll go back to the IQS hub, and people can continue discussing if they'd like.
I actually forgot my question, so you can go ahead. Go for it.
Okay.
I'll try to reform it.
This might actually be a dumb question, but the discussion on tokenization reminded me of certain compression algorithms. What's the difference between tokenization and compression?
Not a great deal. I mean, what's the difference between tokenization and compression? It's a compression, you have a metric, right? So the metric is like, how close to the Shannon limit are you? With tokenization, you're not quite aiming for that kind of compression. You're kind of aiming for semantic evenness. You want the tokens to... I mean, I'm not an expert enough to be able to answer that properly, but there's a slightly different metric that you're aiming for. I guess is a cheap answer.
Okay.
Yeah, I remembered. When we were talking about the Mac Mini as an external driver, etc., and this other question that was asked on the current research you're doing with the data inputs you might be running or whatever the help you're asking for, I was just wondering what would be the best practice in terms of... Sorry, let me reformulate my question. How often, because we assume that they're using everything we give them to train their models and so on. So if me and my team were doing a research that's kind of niche and relatively new and so on, even though there's no publication that's out there online, we are still developing a new creative way of solving a problem. And I'm there discussing with Claude, putting some inputs of data, and I still have an external Mac Mini where I sometimes run things without the internet access. What are the chances of they actually, if someone else is working on somewhere, I don't know, at MIT, this guy is working on satellite decay as well, and he asks, what could be a way to solve this problem with another type of machine learning? Could the model tell him, like, I don't know, in a month's time?
I see what you're
There
going
are
with that,
discussions, but it's not official because he's not citing anything because there's no peer review, but could he, in a month's time, be telling a guy out there at MIT saying, some people are doing this research? How do we know?
There's 2 answers to that, I think.
Thanks.
So answer 1 is you have to assume that that's possible, right? You can't assume that they don't. I mean, they have the information. They accessed it from your computer. They have your chat history. They know it all, right? And so that's the one answer. That's the hyper paranoid answer, right? But then there's the business use case answer. So Anthropic's entire business model depends on companies exploiting their compute to do stuff that's intellectually, is IP endangered, right? You know, IP challenged. If they had even one instance of that happening, of what you're talking about, that was provable or even suspected, that would destroy their value as a company. Like their entire value is based on the idea that they're not doing what you're saying. So that's a trust level thing. You know, do you trust them or not? And it's up to you to make that decision. Like, where do I land on that? If you have a mobile phone in your pocket, you've already decided that you're trusting the provider, Apple or Samsung or whatever, that they're not eavesdropping on you and using that information for their own nefarious purposes, right? We don't think that Apple does, but we know that the government has access to their stuff, so you know you have to assume that they do, right? So you establish a trust relationship with your vendor, I think, is the only answer I can give you. And I don't believe they're going to do it. Like, I really don't, because the value would, it's economically a catastrophe for them. But
Do you do a lot of cloud offline?
I don't bother, no. I do it on, I decided to go full open.
Yeah.
So I'm a no more secrets kind of, everything has to be open now position. I've been turned pretty left wing by AI.
Oh, I made you work. So before we end, you want to just see what...
yeah,
the person who answered the question...
The person who answered the question is gone. But it's doing something, right? It says it's going to take 30 to 60 minutes. So what does it have? It's worked out some bond lengths, it's worked out a relativistic Hamiltonian, some quintets and things. I don't know what it's doing because I don't know about iron oxide. But apparently it's doing something, and it would have been great if that guy was there to say this is garbage or not, right? But what you do see as we scroll through here is a pretty realistic workflow, right? You know, it's worked out the problem, it's written down some Python programs, it's smoke tested them, it's downloaded some database stuff, right? I think these are some databases of wave functions, if I'm not much mistaken, and it's worked out a computation script, and it's executing the script, and now it's trying to get those energies, I guess. And my computer sucks, so it's going to take forever. But yeah, so that's a very, like, the models have gotten so good now. In the old days, this would have been so tedious. You would have had to like break it into little steps and then babysit every step. But now you can just sit and like one shot it.
And with that, let's thank Tobias for his